Today I'm going to look at the Double Award Science. It's the chemistry component and it is the practical skills written paper, that's booklet B. So Unit 7B, or you might know it as Unit 3B. So this is just a 30-minute paper and it's done after your Unit 2 chemistry paper. So first question, hydrated nickel sulfate, NiSO4.xH2O, was placed in an evaporating basin and heated to a constant mass. Explain what's meant by the term heated to constant mass. So you're heating and weighing the evaporating basin until the mass doesn't change. The following mass measurements were obtained during the experiment. So the mass of the evaporating basin was 45.12, the basin with the hydrated salt 50.38, and with the contents after heating to constant mass 48.22. So calculate the mass of hydrated nickel sulfate used in the experiment. So you're taking the 50.38, take away the 45.12, that's the mass of the evaporating basin with the hydrated sulfate, taking away the mass of the evaporating basin, which gives us 5.26 grams. Then the mass of water lost from the compound. So it's the mass of the evaporating basin and the nickel sulfate, which was hydrated, minus the mass at the end when it was heated to constant mass. So that gives you 2.16, so 2.16 grams. Anhydrous copper 2 sulfate can be used to test for water. State the colour change which would be obtained. So we've got white to blue. Then, in an experiment to investigate the rate of reaction, a piece of magnesium ribbon was reacted with an excess of hydrochloric acid at room temperature. The volume of hydrogen gas produced during the reaction was measured at 20-second intervals. Draw a labelled diagram of the apparatus used to carry out this experiment. So, first thing we need is something to react the magnesium ribbon and the hydrochloric acid in. So I've drawn a conical flask and I have labelled both the hydrochloric acid and the magnesium ribbon, and it said in the mark scheme that they must be in contact, and that's 1 mark. The conical flask is your 2nd mark. 3rd mark was for having a delivery tube going from the conical flask to a gas syringe. 4th mark for gas syringe. And then for having that all as a sealed system, so I have here drawn in a little cork or a rubber bung, so that was a mark as well. And then finally, because it says at 20-second intervals up here, then a stop clock or a stopwatch or some other timer. So maximum of 5 for that, from any 5 of those completed correctly. And the results obtained were plotted on a graph which is shown below. And it asks, so you have volume of gas here and time here, and this is the curve which was originally drawn on. At what time did the reaction stop? So you're looking for when the graph levels off, okay? And that's that volume there, you read it off. It's 132. Now they do give plus or minus 2 for that, for error. Explain why the last part of the graph is horizontal, because the reaction has stopped, so there's no more gas being produced. Then it says the experiment was repeated under identical conditions, except that the temperature was 50 degrees. So sketch a curve on the same grid showing how the volume of gas produced would change with time, and label this curve A. So because the temperature has been increased, it's going to be a steeper curve. Okay, so steeper curve here. 1 mark, labelled curve A, and then it levels off at the same volume is your 2nd mark. The salt produced in the reaction, magnesium chloride, is used as a catalyst for the polymerization of ethene. What is meant by the term catalyst? So what we're looking for is just a substance which increases the rate of reaction or speeds up a reaction. So you'll notice there that the 1st mark is for increases, 2nd for rate of reaction, or 1st mark for speeds up, and the 2nd one is for just a reaction. And then 3rd mark without being used up itself, or it's unchanged at the end of the reaction. Question 3. A student is given 3 gas jars labelled A, B and C and told that one contains nitrogen, one contains carbon dioxide, and one contains oxygen. The student doesn't know which gas jar contains which gas. So we have nitrogen, carbon dioxide, and oxygen in these. Give two similarities between the three gases and describe how, using tests for gases, you would work out which gas jar contains nitrogen. So additional gas jars containing A, B, and C are available as needed. So this is one of the ones which is assessed using written communication skills and specialist scientific terms. So just make sure you're using scientific words in this. So similarities, and you could have had a maximum of 2 of these. So all of those gases are colourless, odourless, they're non-toxic, they're tasteless, and they're found in air. So a maximum of 2, because it says 2 similarities here in the question itself. So then for the testing, the idea of a logical order to test all 3, then using a glowing or a lit splint. I would say for oxygen always use a glowing splint, and then the result for that is that it relights a glowing splint, or it burns more brightly if you've used a lit splint. But I would always say use a glowing splint and it relights. And then adding lime water, and that it turns milky with carbon dioxide. I just haven't written in the last bit here, which is that nitrogen is identified. What's going on here? So nitrogen is identified by default. Who knows, sometimes this iPad has funny moments to itself. So the nitrogen is identified by default would be your final one. Now, in terms of the indicative points, if you had 7 to 8 indicative points, you're getting 6 marks, 4 to 6 is 4 marks, and 1 to 3 is 2 marks there. Okay, on to the next one. The presence of copper-2 ions in copper-2 chloride can be shown using a flame test. Diagram shows the equipment needed for the test. Identify the acid, W, the metal wire, X, the colour of Y of the flame before the test, and Z during the test. So the W here is the acid, that's concentrated hydrochloric acid. X is the wire, so they're looking for you to say nichrome or platinum wire. Y is the colour of the flame there. Before you heat it, that's blue. And then Z is green blue. You could say blue-green as well. Both are acceptable. 2 reasons for using W. So nichrome or platinum, W is the acid, so it cleans the wire and it makes the solid stick to the wire, or it dissolves the solid. Okay, moving on to the next one. Sodium and potassium are group 1 metals which react with water. Complete the table below indicating the observations made when each metal is separately added to water with a tick. So burns with an orange flame. Now, they do say in their acceptable colour changes that sodium is yellow, so this question has annoyed me a little bit, but that's sodium. Lilac flame is potassium, and then this turns into a ball. I have been back through the CCEA specification where it doesn't really say anything, but their fact files and their e-guide give contradictory information about which one turns into a ball and which one doesn't. So I actually went to the Royal Society of Chemistry's website to look at theirs, because I would have said both melt and turn into a ball. I don't think it's really a definitive difference between the two. I would have said the main difference here is that potassium is a more vigorous reaction than sodium, and that potassium burns with a lilac flame. This turns into a ball. It comes up in this. It also came up in the separate chemistry GCSE in the specimen paper, and this whole question has angered me, I have to admit. So turns into a ball. The mark scheme says sodium, so that's what we're going to go with, even though CCEA contradict themselves in their fact files and their e-guides, and the Royal Society of Chemistry says that it is potassium. But that's what the mark scheme says. Hopefully, this is specimen. It won't have happened in any of the real papers. Universal indicator was added to water at the end of the reactions for both metals. In both cases, the universal indicator turned purple. Suggests a reason for this is because there's an alkaline solution present. So it's made an alkaline solution. Then the reaction was repeated in a test tube with a tiny piece of sodium. The gas formed was tested with a lighted splint and a squeaky pop was heard. Identify the gas. Well, you really want that question because everybody knows a squeaky pop is hydrogen. So that is the foundation tier Practical B paper. Thanks for watching.